Okay, so this is a second order non-homogeneous differential equation because you have that non-homogeneous forcing term on the right hand side, and to solve it we'll use the method of undetermined coefficients. So first you solve the homogeneous, where you set the differential equation equal to 0. So homogeneous differential equation. So we set this equal to 0. We find the characteristic equation just like we were doing on the previous one. R squared plus omega 0 squared equals 0, which makes R equals plus or minus omega 0I. Which makes what? Y complementary be what? C1 cosine omega 0t plus C2 sine omega 0t. And now we will move into the non-homogeneous. To find the particular solution of the differential equation. So assume solutions of the form. Now usually, because the right hand side is cosine omega 0t, you would assume solutions of the form cosine omega 0t plus sine omega 0t, but that's what you got in your complementary. They repeat. So then you'd have to modify the particular and assume solutions of the form of at cosine omega 0t plus bt sine omega 0t. Instead of cosines and sines, it will be t sine and t cosine. So y particular would be a t cosine omega 0t plus bt sine omega 0t. And a and b are the undetermined coefficients that we are going after. Okay, so now all you have to do is find derivatives, plug it into the differential equation. So y prime, product rule on both terms, we get a cosine omega 0t minus derivative of cosine is minus sine, so this is a t sine omega 0t times the chain rule. We multiply by omega 0, the derivative of omega 0t. The same thing applies on the second one. So we get b sine omega 0t plus product rule b t cosine omega 0t, and the derivative of omega 0t is omega 0. So that's y prime. And now we will find y double prime. So minus a omega 0 sine. You're doing that, Ben? You should be practicing. This is important. You have a question? You know what to do?
Yeah.
You got the homogeneous terms, yeah?
Yeah, I got that.
Okay, no problem there. So you know how we thought about the non-homogeneous?
the particular. So what was the, how would you find the particular with the cosine?
Well, what derivatives generate cosine? Sine and cosine.
Yeah.
The only thing is, when you did your homogeneous, and that's why we did the homogeneous, to figure out what the complementary is, it turned out that we got cosines and sines in the complementary.
Yeah.
So you would have to modify the particular. Instead of sines and cosines, now you have to have t cosines and t sines.
Right.
You multiply it by t. Yeah, because it repeats. No? Okay, so second derivative, so sine omega 0 t. Product rule on the second one, so minus a omega 0. Derivative of t is 1, so this stays sine omega 0 t minus a t omega 0. Derivative of sine omega 0 t is cosine omega 0 t. Chain rule on the inside times omega 0, so this becomes omega 0 squared. Plus b omega 0 cosine omega 0 t, and then product rule again on the last one, plus b omega 0. Derivative of t is 1, cosine omega 0 t minus b omega 0 t. Derivative of cosine is sine omega 0 t times the derivative of omega 0 t is omega 0, so this becomes omega 0 squared. And that's supposed to equal the forcing term of the non-homogeneous, which is cosine omega 0 t. Oh, that's just the second derivative. We didn't put this together yet, so never mind. So now we'll plug those in the differential equation. So let's see here if we have any like terms. We have, yeah, let's massage this. So we get y double prime equals, these two signs here are like terms, so right here, so this is minus 2 omega 0 sine omega 0 t, and then we have these two terms are the same, so this is plus 2b omega 0 cosine omega 0 t, and then minus a t omega 0 squared cosine omega 0 t minus b omega 0 squared t sine omega 0 t. And now, after we did this massage, we will plug everything back into the differential equation. The homogeneous differential, the non-homogeneous differential equation. So we get y double prime, so minus 2 omega 0 sine omega 0 t plus 2b omega 0 cosine omega 0 t minus a t omega omega 0 squared cosine omega 0 t minus b omega 0 squared t sine omega 0 t. That's y double prime plus omega 0 squared y. So plus a omega 0 squared t cosine omega 0 t. We're multiplying y particular by omega 0 squared plus b omega 0 squared t sine omega 0 t. And this has to equal the cosine omega 0 t. Okay, so now let's collect the likies, if there are any. No? So we've got this and this go away. The sine t sine omega 0 t and this go away. And all we have left is, wait, we forgot a coefficient here. There's an a here, negative 2a. So there's a negative 2. Let me insert an a here. Negative 2a. Let me make this clear. Minus 2. So there's no sign on the other side. So negative 2a has to equal 0 because there's no sign on the right hand side. That makes a equal 0. Now, if we zoom back down, 2b on the other hand has to equal 1. 2b omega 0 has to equal 1 because this and this are the same, and the coefficient of this is right here. So now we can say, okay, great, 2b omega 0 equals 1, which makes b equals 1 over 2 omega 0. And now we can take that coefficient and plug it back into our assumed solution. So our assumed solution was a t cosine omega t, which goes away because a is 0, so we have b t sine omega 0 t. B is 1 over 2 omega 0. That's our b, and then t sine omega 0 t. That's the particular solution of the non-homogeneous differential equation. And now if we want the general solution is just the sum of the complementary and the particular solution of the differential equation. So we can write down our y general to be y complementary plus y particular. So y complementary turned out to be c1 cosine omega 0 t plus c2 sine omega 0 t plus the particular solution, which is 1 over 2 omega 0 t sine omega 0 t. And those C1 and C2 can be determined from initial and or boundary conditions. And that does it for this question. Any questions here, Ren, on the process?
Um, the particular solution doesn't